Welcome to this Think Small Cell webinar. Today I'm joined by Eric Colard from Microsemi, and we're going to be talking about overcoming the high deployment costs of synchronizing enterprise small cells. Now, before I hand over to Eric, who's going to give a presentation followed by a question and answer session, I'd just like to remind you that this webinar is being recorded, and everybody who's attended will get a link to the recording, and the slides that you'll see will also be available for download. And again, you'll get an automated email with a link to that. So without further ado, I'm going to hand over to Eric, who's the director of the emerging line of business at the Timing and Synchronization division of Microsemi, for him to take you through the presentation. So over to you, Eric.
So hello everyone, good morning, good afternoon, good evening, depending on where you guys are. Thank you for joining the webinar today. I will cover today, for those of you who are not very familiar with timing hurdles for indoor deployments, I'll cover first what problem there is to solve for operators, especially in the context of deploying indoor environments and small cells. Then I'll cover the innovation and disruption, the solution that we actually brought to the market and announced a few weeks ago at Mobile World Congress. And as David indicated, we'll go through a Q&A. So first of all, in terms of the context and the market, Microsemi is a member of the Small Cell Forum, and the Small Cell Forum indicated in one of their reports that about 80% of the traffic today related to small cells is actually indoor. It's very, intuitive to understand. When you use a smartphone, you're probably sitting somewhere in a coffee shop, at the office, in other environments, at the hotel. So it's very intuitive to understand. Delivering precise timing to that type of environment in a cost-effective way is actually not very easy to perform. And we'll go over what type of hurdles operators have to go through to actually make that happen in a cost-effective way. Is there actually a market for these types of situations? Is there a set of issues to solve in the marketplace today? And you can see on the bottom left corner of the slide that among all the operators that deploy small cells today, the estimation is about 44%. 44 of these operators actually do that in an enterprise setting with small cells. So it's happening today. It's actually growing according to many of the reports in the industry. And one of the reasons why is actually because small cells offer, additional coverage and additional capacity, and the cost savings compared to deploying macro cells are pretty obvious. If you look at the bottom right corner of the slide, that kind of compares over time, over a period of 8 years, the OPEX between a macro cell and some small cells. So the growth is there, the market is there, but there are some issues related to timing and synchronization of those environments, and that's what I'm going to try to explain in this slide deck introduction. So most of the small cells, as you may know, are being deployed in an LTE environment. There was a lot of 3G deployments in terms of residential femtocells, residential small cells. We are not discussing this here. I mean, we focused between the residential small cell and the macro, all these types of devices in between. That's what we're considering as being small cells. And these small cells today are being deployed mainly over LTE, and as we said, mainly indoor. And the requirements in terms of timing and sync for these types of environments are very stringent. 1.5 microsecond for time and phase support. And just a clarification, phase is not only required for LTE TDD, as many people know. but is also required every time you have some form of coordination because of interference mitigations. So when you deploy EIC-IC, COMP, MBMS, all of these types of technologies, even if you're not in an LTE TDD environment, would require phase. So phase support is actually much more widespread than some people may realize. So to provide time and phase for these types of environments, you have a set of potential options in terms of timing and synchronization technologies. Of course, GPS and GNSS is sometimes favored, but there are some indoor limitations for those types of deployments. But the main limitation is also a business model limitation. Embedding GPS, providing GPS antennas within small cell products indoor is not always cost effective. And doing it on every single small cell is maybe not the most efficient way of deploying timing and phase. We have always believed at Microsemi that timing and phase solutions need actually to be distributed and providing timing and phase to small cells and to other environments rather than being embedded into these dedicated products that perform other functions. And TP has been used, very adequately in the femtocell residential environment, but for small cells, for phase, and for LTE deployments, that's not a very prevalent technology and probably not adequate, to meet the requirements. MacroSniff is another potential avenue, but not always usable, where coverage issues are actually the main reason for deploying small cells. And so a lot of the operators are actually leaning towards PTP 1588, and there are some deployment considerations that I'd like to go over. So there are some challenges for deployment of timing and synchronization for small cells. So in the traditional model, you need to provide very accurate timing to small cells that may be at different floors. You usually have one or more small cells at every floor in a building. And timing, providing timing to those small cells requires some type of grandmaster for 1588, in the case of 1588 synchronization. Most of the time, the traditional model is to deploy a 1588 grandmaster in a dedicated hardware platform that will be deployed in the same server room as your switch in the building, as your network internet device NID in the building, in your server room, basically. And to provide very accurate time and phase, you need GPS source of time. And that would be provided by the GPS antenna on the roof. And from there, you can see the illustration on the diagram. There's a practical issue there. You need access to the roof. That may mean, a permit in some countries, in some cities, in some buildings. You may need to rent, the space on the roof for the GPS antenna. Then you have to go through every floor, through the roof first, and then every floor to actually drill and get the conduit with the GPS cable through each floor down to the server room where the master is. So there are cabling issues, rent and fees and permit issues, not only for the roof, but sometimes for the floor themselves because of fire, rules for the building walls and ceilings, installation costs. So not very easy proposition. I mean, it can be done. We've done it. Many operators have done it, but it's not very cost effective. And because it's not a macro environment, the small cells themselves are becoming smaller and cheaper. And so it's becoming less and less effective to deploy this type of environment for syncing small cells. So I will contrast, this traditional model with what we are proposing later in this slide deck in terms of the solution that we brought to the market. So the traditional model is a grandmaster. So you need to buy the grandmaster, you need to buy the GPS antenna, the permits, the, the space on the roof. You need to buy the cabling, potential amplifiers, the splitters, to spread the GPS signal across the building, installations. And I'm not talking here also about weather-related issues. If you have a GPS antenna on the roof, if it snows, your signal may be becoming very weak and disturbed. You may be in some countries where there are animals, that may interfere with the GPS installation on the roof. So there's all kinds of CapEx issues. And then OpEx-wise, over time, the powering of the device and the antennas, the cooling, the rental cost and the monitoring and management, all of those add up. And we'll go over on a later slide over the total cost of that type of deployment hurdles. So just to illustrate what I'm talking about, I'm actually going to show you a real-life deployment that we've made in a hotel in San Francisco. So Microsemi has a deployment with an operator in that hotel. And I'm going to show you kind of the practical issues that we had to face. And we went there to take some pictures, myself and the sales team, to kind of illustrate to you a real life scenario. So this is the traditional model with one of our traditional grandmasters and an antenna. So this hotel is actually split into two areas. There's a hotel about 15, 16 floors, and then above that there are apartments managed by the hotel. This deployment is mainly for the hotel rooms, 15 floor of hotel rooms. So if you see the tower, not very easy to put an antenna on the roof. This hotel actually was in a kind of lucky situation. If you look at the bottom, I show with a red arrow the GPS antenna location. So it's not on the top, roof. It's on a terrace over the conference rooms of the hotel. So they were lucky to find a location to put the antenna much lower than on the rooftop. So you can see the antenna on the terrace. And then if you moving to the next slide, actually showing you the type of practical details you have to consider. So on the top left, you see the conduit that goes from the GPS antenna to inside the building. So it's a modern building going from outdoor to indoor, and having a conduit of that nature go through indoor is not very easy, not very practical. And I'm showing on the bottom right the type of conduit, in orange, where the GPS cable, which is on the left side, so the GPS white cable is actually going through the orange conduit. And you can compare that to the Ethernet cable, which is the yellow small cable on the picture. Some people may not realize how thick, a GPS conduit and cable installation is involved here. So I thought it'd be nice to show you a real life situation that we deployed. And this is kind of the environment where you have a bunch of antennas for the small cells that are distributed across the floor, 4 or 5 antennas on the floor. And then the small cell itself is in a cabinet at each floor. You have these types of small cells in the hotel. So that's kind of the environment. I'm not showing here the grandmaster and where it's set. I kind of focused on the small cells, the GPS antenna, but there's a grandmaster at the lower floor connected to these via Ethernet, and the GPS cable is connected to the GPS antenna outside. So it's a pretty involved type of setup. I'm going to hand it to David, who has a poll to ask you.
Thank you, Eric. Yeah, I'd just like to take this opportunity to ask the audience whether you believe in the context of enterprise small cell deployments, whether the costs of deploying these external GPS antenna are significant. And you should see on your screen now a voting box appear, and you can pick whichever one of those options you think is most relevant. So votes coming in. Over half our viewers have voted already. If I could encourage you to make your choice, and I'll close the poll in 5, 4, 3, 2, 1 now. Okay, and I'll just share the results. You should see those on your screen now. And Eric, would you like to make any comment about that?
Yeah, so the first one is I'm glad to see that most people think these costs are not insignificant, and that a fair number believe extremely and moderately important is their answers. So that kind of correlates to what we've seen in the marketplace, and I'll show you in a later slide what we heard from operators and also network equipment manufacturers, which kind of is in line with the results of this poll. So thank you very much for answering to everyone who did answer the poll. This is the kind of the feedback and the market requirements, based on the types of deployments that we've made and the hurdles that operators were facing. We kind of had a lot of interactions over the years. As you know, Microsemi is the leader in timing and synchronization, especially 1588 products. We're definitely the worldwide leader. So we had a lot of interactions with not only operators, but also small cell and equipment manufacturers. And so we got a set of requirements from the industry. First of all was solve indoor GNSS operations in terms of timing and sync. And that relates to what we've just seen, driven by deployment cost and save, kind of provide a solution that would solve the cabling and deployment issues. The other feedback we got from the marketplace is related to form factor and also the functions of the devices. If you're in the central office, you might accept, an environment where you have one box for each function. A box that does a switch, a box that does a grandmaster, and so forth. In a small cell environment, and especially in the enterprise, operators have been requesting that functions be integrated into one single device, or as minimum number of devices as possible in the environment. And so that's what we will show in this presentation, that we heard the industry and integrated more than one function into the product that we are bringing to the market. Small form factor. One very, very important aspect, of course, is cost. It needs to be in line with the cost themselves of the small cells, and plug and play. You may be familiar that most of the timing solutions, require some configuration for 1588 and other parameters. These usually are done by timing experts and are done with a specialized management platform. The requirement we got is in the small cell environment, the timing products indoor will not be deployed at the operator environments. They will be deployed in the enterprise, for example. And the timing experts are not there. The operator personnel is not there. So there's a requirement to be very similar to small cells. Just like small cells are being deployed in a plug-and-play auto-configuration mode, our master that we will unveil in this presentation is also following the same plug-and-play, auto-configurable, easy to manage and install type of paradigm. So this is the feedback that we heard from the industry. So what we announced recently at the Mobile World Congress is actually a very innovative, we think, and disruptive way of deploying timing and synchronization for indoor environments. We focus the message on small cells, but it's not only for small cells, it's for any type of indoor environment. So we have innovated. We didn't produce, let's say, a Grandmaster traditional with a smaller form factor, a smaller box. We wanted to listen to the operators and the hurdles that we are facing as an industry and to reduce the deployment cost. And so we announced the integrated GNSS master. Moving to the next slide, there's always a little bit of delay between when I click and when it appears. So you can see on the first bar, the green bar, the device itself. So it's meant to be deployed indoor. It's integrated. The way it's integrated is if you open up the box, inside the master, you have the 1588 Grandmaster, of course. You have the GNSS antenna. So you have no need for an external antenna anymore. The receiver and the cabling linking the receiver and the antenna, everything is integrated in the small form factor that you show here. So it's a cost-effective solution. The way you deploy the product is you actually connect this product to a switch, for example, that then connects to the small cells, and all of that is through Ethernet. So Ethernet is very prevalent in buildings across the world nowadays. So we just use a regular Ethernet cable, no more thick conduits for GPS cabling. You may or may not know, but Microsemi is actually the inventor of power over Ethernet. We acquired a company several years ago that invented PoE. Microsemi has a very wide portfolio of PoE mid-spans. So you can, in addition to deploying the product and linking to a regular switch, you can also include a PoE midspan in the environment and power not only this product, the IGM, but also the small cells with power over Ethernet. And that was a big requirement from operators as well to be able to leverage PoE. And lastly, plug and play. So the product doesn't require any configuration by the installer. There's an auto-configuration server mechanism via a standard mechanism, by the way, where the product gets auto-configured. There's only a need to pick a location for the IGM 1100 inside the building, and it can be installed on the roof, on the ceiling, or on the wall, and in a room in the building, and it's auto-configured. By the way, we have also a management platform separate from this that the operator might use, and I'll go over that in another slide. So there's a combination of auto-configuration for easy installation and also management capabilities from an operator point of view. So this is a recap of what we discussed early in the presentation. So in the gray box, you see all the costs that we discussed. The cable installation, the permits, the roof rentals, the weather protection, power and lightning, the cabling, potential amplifiers, splitters, how to deal with power, and the wall permits for fireproof walls. So the combination of all of these costs, I wanted to contrast the traditional way, like we've done in the hotel, and this new innovative way. So the traditional way is the right column in that table, where you have to buy the device. Let's say, as an example, it's probably around $1,000 if you buy a traditional very small form factor Grandmaster. You need to buy the antenna, you need to buy the receiver, the cabling. It's going to end up being, probably between $2,500 and $3,000. That's about the price, the list price of the device that we are actually presenting here today, which includes everything. So the cost of both solutions are very similar from that point of view. But what it takes to actually deploy after you buy these pieces of hardware is very different. So in the traditional PTP Grandmaster case where it sits in the server room, like we discussed in the hotel, we estimate, depending on the region, depending on whether you are in Europe, in the US, in Asia, whether it's a very dense city like Hong Kong or whether it's in the middle of Kansas, these are different costs, the size of the building. So uh, these numbers are averages, of course, right? But from what we've seen, and the reason why we know these types of numbers, we actually deploy a lot of GPS environments with our masters today. So the average price is probably between 15, 20K to up to 65K. We've seen this number in Hong Kong. Just the cost of renting a space on the roof itself and the monthly recurring fee for doing that is very, very high. So these types of numbers compare to deploying the IGM in a room in the building, which is very similar to deploying a Wi-Fi access point. So the cost is very minimal. So that's where the big saving occurs. So to go over the key features and functions of the IGM 1100i. So first of all, as we discussed, 1588 Grandmaster, GNSS receiver, and GNSS antenna all in one product. GNSS today is for us, it's support for GPS, support for GLONASS, it's support for QZSS in Japan. The product is enabled for Beidou 2 and also for Galileo. When they become commercially widespread, we have a commitment to support these constellations. But today it's mainly GPS, GLONASS, and QZSS. Enhance indoor capabilities, and I have a slide that kind of gives you some ideas of why does it work indoor. And the reason it works indoor is we have a combination of an algorithm, proprietary technology that I'll describe a little more details later, and also the use of assisted GNSS. So you have the receiver in the product that's a pretty good receiver. Assisted GNSS is providing much more enablement for acceleration of time to first fix. So it helps a lot. So using assisted GNSS is very important. And the proprietary secret sauce, if you wish, that we add, the combination of these three things explain why the technology works indoor. In terms of 1588, it's not because it's a smaller device, a lower cost device, that we have limited or reduced the capabilities. This device has the latest, greatest that you can find in other Grandmasters that Microsemi makes available. So we share the technology with other Grandmasters. So we support 1588 both for frequency and for phase. And we have the latest ITU-T profiles supported. So both layer 3 unicast and layer 2 multicast, the latest phase profiles that were agreed a few months ago. And in terms of management, like I was alluding to, the product is auto-configurable. So there's an ACS server that actually enables the devices to be configured, no installation configuration. The product sends alarms and traps, and there are also LEDs that you can see on the picture. So we have LEDs for network status, sync status, and also alarms and traps. So all of that set of alarms and traps is captured to show on the device itself in the form of LED lights. It's captured by the auto configuration server, and also is captured by the Time Pictra, which is our management platform, which manages the whole family of products for timing and sync in the operator network. So if an operator already has Time Pictra and manages other products from Microsemi, will be also able to manage the IGM 1100i and see all the data that's coming through alarms and traps as well. So that's a slide that attempts to give you some notions, and I will not go into much details on that because it's what I would describe as the secret sauce that we provide in addition to the receiver that's in the box and the GNSS assistance. It is what we actually do in the box with special algorithms. So we have multiple patents in the arena of kind of making sense out of weak signals that come from satellites. And that's really where the secret sauce lies in the technology. In addition to that, you're probably wondering, how we deal with the holdover and these types of situations. So we have, like in other products that we have in the family of packet time solutions, we always make sure that we have an optimal and efficient way of managing the oscillator in the box. So we have advanced thermal control algorithms and packaging of the oscillator that we use in the product to allow for some holdover in case there's a disruption. In addition to that, we, being a PTP house and knowing a lot about PTP, as you know, we think that PTP input, and I'll show that in the slide a bit later, is very important aspect of reliability and performance. So the combination of these three things actually make what we think is very unique in the industry, in addition to the hardware. And that's where the secret sauce comes from. So you may have heard of Best Time, which is a set of technologies that we have promoted when Symmetricom was around and then got acquired by Microsemi. This is an extension and an enhancement of the Best Time set of technologies that we use for timing and sync in our products. So I said it's low cost and cost effective and a small form factor. These are the dimensions of the product that you can see on the left. About 6 by 7 roughly inch type of product. I put there on the right side the UVerse, AT&T UVerse, DSL box that I have at home. Those of you who have similar products at home, you can relate to kind of the size. It's very similar in terms of size to that Wi-Fi DSL access point that you may have at your home. So in terms of the typical deployment that you would consider in a building, so the product doesn't need to be in the server room anymore, right? So we show the server room at the bottom of the slide. The product, the IGM, can be anywhere in the building, preferably not in the server room, so it gives you more flexibility. So we have an application on a smartphone that an installer can use that shows how many satellites can be used. So the installer can just start the application, the app on the smartphone, look whether there are 2 satellites minimum usable, walking around in a specific room where the IGM would be a potential location. And if there's 2 satellites being usable in a particular location, you can draw a circle of 10 feet around that, and you can deploy IGM there. So there are many locations you can walk as an installer and see 2 satellites and pick a location that makes sense in the building. So it's very flexible from that point of view. We've done a lot of tests. We've done testing in our own building, for example, where we have very bad cellular coverage. As an example, at the engineering floor, at the first floor, the IGM product works at that floor. We've done testing in libraries and other buildings, Starbucks, many locations in many cities across the US so far. And we have a lot of data on the types of buildings where we have done the testing that we can share at a later time. So there's more flexibility actually than we thought at the beginning of the project. And we're very confident about the type of deployment flexibility that can be allowed to an installer. So the picture here on the left shows clearly that there's no need for a GPS antenna anymore. So you just deploy the GNSS Grandmaster either on the wall or on the ceiling. You connect it to the servers and the switch, the PoE midspans via an Ethernet cable. The small cells are, anywhere in the building, it doesn't matter, and timing and sync is provided to them. Just a word on redundancy. This is a device that's different from all the other products that we've built, where we have, carrier grade, very redundant boxes. That's been kind of a forte of Microsemi over the years. So this product provides for redundancy in a failover mode. So if you deploy a few of these devices in the building, for example, let's say 2 in this picture, and you allow for failover, extra capacity in the device, then the master will actually take over the slaves from a master that fails. And the master doesn't need to know or be coordinated between themselves. The best grandmaster algorithm defined by 1588 from the slave side is going to define, itself, which master to connect to. So if one fails, the client automatically will find another master to connect to based on that 1588 algorithm. So in terms of management, as I was saying, we build the product to be seamlessly fitting within the small cell deployment strategy that operators have. And most of the small cells that we've seen self-configure and do not require a heavy touch from the installer. So that's exactly the type of paradigm that we fit into. So we have auto configuration. We connect, to DHCP servers, to TR69 for ACS. And as I said before, and I'll show it in more visual way, we have also a time picture platform that usually an operator might use for other products by Microsemi, and that also can manage the IGM product. So that's kind of what I wanted to show. It's kind of the end-to-end view and the benefits that an operator may find in connecting the IGM in buildings with the rest of the infrastructure. So if I show here on the right side, there's a building with a few units of IGM. So there's no problem, they work. They serve the small cells in the building. But as most operators in the world do, they probably have other products by Microsemi in the environment. It's taking some time to show up. Okay, so if you are an operator, you may have, at the core of the network, you may have traditional sync type of products, to sync your, 2G or 3G environment, for example, SSU type of products. You may have grandmasters in the environment already, either a TP5000 as an example or TP2700. That environment exists. So there's no requirement to connect it to the IGM in the buildings. The IGM in the buildings serve the building and the small cells. But if you do, as an operator, connect the existing infrastructure with the IGMs in the building, and you do that allowing, for example, PTP input and sync key input, then the environment in the building becomes much more reliable and much more solid. So if 1588 is present in the infrastructure and GPS goes down, for example, the IGM will be in holdover for a period of time, but then we'll be able to leverage PTP from the operator infrastructure and keep working even if GNSS is not available. So it's a backup to GNSS mechanism that we think we have always worked with operators, making these types of statements that PTP is very important also as a backup to GNSS. And so that's the type of situation that you could leverage as an operator. And sync key input could also be very valuable if sync key is in the environment. Providing sync key input to the IGM would provide for very good frequency stability and provide for a better phase performance consequently. So connecting IGM to the rest of the portfolio in the operator network is very good for backup and also for frequency input and reliability. And you can see on top the time picture end-to-end synchronization network management. So if you have the time picture in the environment to manage the SSUs, to manage the TP 5000 or 2700, then you can also manage the IGM from the same platform. And by the way, because we have also a PoE portfolio, you can also manage the PoE products that you would use in the building with the same time picture. So we allow for both, for a very hands-off, no installation, no configuration type of setup, but we can also allow for a much more involved by the operator visibility of end-to-end time and sync capabilities by the operator. And we think it's a very good and very differentiated benefit that Microsemi can bring in the environment. So that kind of concludes my presentation about this new Grandmaster that we announced about 6 weeks ago now, the IGM 1100i, which, very focused goal of deployment cost reductions, indoor in particular. Small cells is an obvious target, but any type of indoor environment would be beneficial for this type, would benefit from this type of product. As I said, the main thing to remember as well is there's no need for an outdoor GNSS antenna for this type of product. The product integrates all of these capabilities in one box in a cost-effective way and includes best of breed 1588, so the latest profiles, and is easy to manage, auto-configures, and we provide tools to help an installer to find the best location in the building. So David?
Okay. Thanks very much, Eric. That was a very thorough presentation. We now have the opportunity for our audience to ask questions of Eric. Any clarification or follow-up on what he's covered, or even questions about whether you disagree with some of the points made. And that's perhaps one of the areas where I could ask you, Eric, first. We've had a few comments come in. And I should say it's you can submit questions on the box on the right-hand side of your screen. But there's been a few questions come in that are just perhaps a little bit skeptical that this would work in some of the more challenging urban environments deep inside buildings. And I just wondered what percentage of the buildings that you've looked at would you expect the solution to be able to work?
Yes, so when we set out to build the product, our internal goal was to address at least 80% of the situations. I mean, we know that there are probably out there a few cases that are, not feasible underground, with no visibility to satellite. So there are some cases like that we knew, the product would not be 100% of the cases. But what we've done, as I said, with all the measurements that we've done over a number of months in various locations, small buildings, tall buildings, Silicon Valley type of environment, campus type of environments, cities with tall buildings. So we've done a lot of testing, and we feel now that we're probably in the 90% range. There are going to be some more difficult cases, but for most of the cases, we think the product will work. And we have deployment guidelines. As I mentioned, we have an app that we suggest to use for an installer to find a good location in the building. And we will publish these deployment guidelines in the user guide that we have in the product. But to summarize, we think it's around probably 90% of the cases will be covered.
So some people are asking what the GPS sensitivity in dBm is, and we also have a question about which of the GPS signals are being used. Whether you want to cover that in in specific detail, or talk more generally about the kind of secret sauce that you've mentioned that make this work effectively in these difficult conditions.
Yeah, so today we use L1, signals, and we assisted by assisted GNSS. We can connect to various assisted GNSS providers. I'd rather not, discuss the specific numbers for the receiver we use, but on a one-on-one basis with customers that would, or attendees who want to reach out to me, we can discuss this in more detail. But as I said in the presentation, the receiver is just one element of the solution. The combination of the receiver and the assistance via GNSS and the secret sauce that I described in the slide. The knowledge we have about how to make holdover, happen and efficient is very important for this type of product. The PTP expertise we have to provide best of class PTP capabilities, but also PTP input as an example is very important. And the core of the secret sauce is really making sense of weak signals, and the patents we have around that. These are, very extremely important. So without those, you wouldn't have a solution.
Just very quick clarification point. When you're talking about assisted GPS, does that mean that the device needs to have a SIM card, or is this something that's getting information through another source?
Yeah, so we don't need a SIM card, you're right. We basically get ephemeris and almanac data through the network. So depending on whether the operator is hosting a GNSS service in their own data centers or whether they have a contract with a GNSS provider that is hosting these servers. In any case, we get the data through the network. So there's no need for it. Doesn't come from the radio signal or this type from the cellular environment. It comes from the network, and we just use these types of data.
Right, right. So clearly, you've got the in-building system fully phase synchronized. How does that align with what the macro cell phase synchronization is doing? Do you need to have some 1588 connection between the two systems to make sure they're aligned?
No, we don't need to be connected to the macros. Basically, the 1588 master is getting the time from the GPS environment, not from the macros. So, and then synchronizing with the small cells in the environment. So just like the product doesn't need to be connected to the infrastructure, the TP5000 and the likes that I showed in one of the latest slides. There's no requirement for doing that. By the same token, there's no requirement for the IGM to be connected to the macros themselves. So the source of time is really the GPS signal.
Right. Another question concerns dimensioning rules or the scalability. Is there a limit to the number of LTE access points or PTP clients that the unit can drive?
Yes, so today the way we are actually selling the product is we have two versions. So we have a version, the base version is serving 4 small cells, and there's a version that serves 8 small cells.
So somebody's pointed out in a data sheet they've seen it set up to 16 clients.
Yes, so there was a prior version of the datasheet that was stating that, but that has been corrected since, hopefully. I think it is corrected. But that's the number that we have chosen, to market today. And I'll leave it at that.
Okay, I mean, I assume that even in the best circumstances, there are occasionally some GNSS outages for various reasons. What's your recommendation to deal with those situations? And does the box have holdover capability?
Yeah, so we have two recommendations. I mean, there are two aspects to it. One is the holdover itself, and the box. We've done testing, and we're continuing to do testing. Um, and there are some, depending on what you call the performance of the holdover, how tight you want the holdover to be, with the utmost performance that we strive to get to at Microsemi. The technology we have for thermal compensation and the packaging that we've done around that of the oscillator allows us up to 1 hour of holdover. So in that period of time, the product can continue working. The recommendation we have is, and usually the outage might actually not last that long. The recommendation we have is what I showed in a prior slide, which is to provide PTP input from the operator infrastructure and feed PTP input from another master in the infrastructure as a backup to GNSS. And in that situation, the combination of the holdover capabilities of the box itself, plus the backup from PTP in the infrastructure allows for a very solid and reliable solution. So we view it ourselves as a timing sync company. We view it more as one element of a family that is deployed in the operator network, even though it's in the building, and leveraging the operator environment.
Thanks. Another very quick question, really, about the installation. Does the installer need to input the position? Given that it's a GPS system, does it need to know where it is before it starts synchronizing or initializing?
Yeah, the initial location is an input to the product. Yes.
And likewise, the sync E input, is that why is that required?
No, sync key input is not required. Actually, when I was talking about the sync key input was in the context of potentially leveraging sync key that may be deployed by the operator in the rest of the infrastructure. If it's there, it's not required. And it's actually the first release doesn't have sync key input. I was talking more about what could the operator do if they wanted to leverage other benefits that they have deployed in their own infrastructure outside of the building. So if that was the case, Sync-key could be valuable potentially for providing stable frequency, but it's not a requirement. I mean, it's required by some operators, so that's why I stressed the fact, because some operators um, believe very strongly that Sync-key frequency is a requirement. So I was making that point.
So probably just following up on your last comment there. There's a number of phase standards in the ITU-T that are new. So how capable is this solution relating to these latest phase standards?
So all the phase standards that have been uh, agreed upon that are in the standard are in this product. So AD 275.1, as an example, it is in this product. We are, as people probably know in the audience, one of the driving force in the ITU-T, and we're very involved. So we know exactly where the discussions are going, and our products have always implemented even pre-agreed versions of the latest profiles before they become official. And then when they become official, we definitely very quickly after provide the official profile. So all the official profiles that have been signed within the ITU-T are in this product release. So it has the same capabilities as a bigger, more expensive, master. It's not because it's a smaller device that it doesn't have the latest.
Right. Another installation question about cabling. Clearly, that GPS cabling you had before was pretty expensive and thick. Does the Ethernet standard length of cable apply when using this product? And is there any requirement for a particular category of cable, the 5E, 6, or 6A?
Well, of course, the GPS cabling length limitations would apply. But we've seen, like for example, well, first of all, most of the environments in enterprises may not reach that limit. For example, at Microsemi, we are a two-floor building. We probably will not need to go beyond the limit. But in the cases where the limit is reached, for example, in the hotel I was showing, definitely it was going over the limit, and there are situations where you go from Ethernet to fiber, for example, to deal with these length issues. And there are media converter situations that would deal with these types of length limitations. So it's not a limitation that's specific to the IGM. They can be solved, and they are solved, in deployments across the world. So there's nothing new about this type of scenarios. So Cat5, is okay.
But typically, standard Cat5 cable would be used that could carry the
That's right.
power, and that would be
That's
more
right.
than enough.
Yep.
Okay, I think we're just about at the top of the hour. So thank you to everybody who's submitted questions. I'm afraid we haven't had time to answer every single one, but I think we've got most of the general themes in there. And I think Eric's done a great job in fielding those. If you would like further information about the product itself, you can go to the Microsemi website, and you can see the link there. We'll send all of our attendees a link to the slides that you've just seen, to the recording, and also the link you can see on the screen. And with that, I'd like to give my thanks to Eric for such an excellent presentation and Q&A session. And thanks to all the viewers for watching, and conclude this webinar. Thanks very much for your time.
Thanks, everyone.